Okay, so what's happening in the first equation? A. So up here, describe in words and sketch. A. So what's happening in that problem?
Height's multiplied by -2.
So the height is multiplied by -2. Okay, what else is happening? It's going left 1. Is everybody okay with that? Now, somebody might say it's being flipped upside down. And that would be okay too, because it is being flipped upside down, right? When you times the height by -2, the tops of the hills are going to become the bottoms of the valleys, right? Okay. All right, so everybody understands what's happening. Now we have to sketch it. Simple shape. All right, how high, I'm gonna do it one step at a time. You can do it together if you want, but how high is that original big triangle there? 2? But I'm multiplying that by -2. So now it's gonna go down 4. So that triangle, instead of going over 2 and up 2, which is what it did in the original, it's gonna go over 2 and down 4. I'm not done. This is my first step. I'm taking care of the flipping and stretching. Now, what about the little triangle? It's originally over 1 down 2. So what's going to happen? It's going to go over 1 and up 4. And there we go. Not done yet, but that's step 1. Are you okay with that? Now, what else did you say had to happen? Had to go left 1. So, all right. I'm going to take everything and move it left 1. So I'll do it right here on the picture. If I go left 1, this is going to be over here now. Over here. Over here. So there's my triangle. And then this point's over here. This is going to be up here. And the blue thing is what you should end up with. Now, does anybody have any confusion about what just happened?
So do you just put it, like you just multiply it by 2 or wherever the point is that we show us on the graph? So I'm just doing 2 times -2. And putting that
Yes, the height.
Oh.
The height. With that, the number out in front multiplies the height, which is the y.
Okay.
Yeah, so I'm doing the y value. When I times by 2 or -2.
The other one, the second one, when you go up, when you do that by
2.
2.
All the heights are getting times by -2.
Okay.
So when it was down, it now is going up.
Okay.
All the y's, height, got times by -2. All right, what's happening in the second one? This is exactly what your quiz tomorrow is going to look like. What's happening in this one? What changes are we making?
Is it bottoms up?
It's going, now be careful, it actually isn't going upside down, it is flipping sideways. Right, guys? We gotta pay attention to where the negative is. So this is gonna be a sideways flip, which means the fat triangle will be over here and the skinny triangle will be over here. All right, so I'm just gonna start with that. So I'm doing the sideways flip first, which is the negative part. So my little triangle is going to go left and my big triangle is going to go right. No size changed. The only thing that changed is instead of going right 1 and down 2, I went left 1 and down 2 because I'm switching sides. Now I gotta take it up 1. So I'm gonna think of this line right here. You actually have a line on your graph paper, so everything's coming up 1. And I didn't do a different color, but that's, every point just got lifted up 1. Okay, so our quiz tomorrow will look exactly like this. I'll give you a shape, I'll give you 2 equations, you'll graph them and write down what is going on. Like up 1, sideways flip. Okay? Now, to help us, we'll do a couple more and then we're moving on. But we'll do a couple more. So get out the graph practice. Sideways flip and up 1. Sideways flip, up 1. All right, now there's a whole bunch of problems here, but we don't have time to do them all. So it looks like this. You got it a couple days ago. We haven't worked on it yet. So graph practice 1 has that shape, graph practice 2 has a different shape. Let's do 1 from each page, okay? So look at the front side of graph practice 1. Which one would you like to do? Which problem? 1, 2, 3, 4, 5, 6, or 7? 5? All right, 5 it is. I'm going to draw 1, 2, 3, 4. I'm going to draw my original up here. All right, there's my original. All right, now I'm doing problem 5, which is what? What is the change that's happening on this one?
Everything on the bottom.
Bottoms up. Yep, everything on the bottom comes up. I call it bottoms up. You can call it whatever you want, as long as it means that we're coming up. Okay? Mizzy, what are you looking for? No. What are you looking for? Here, just take this one, and then don't lose this one, okay, honey? Hang on to that one. All right, so I'm gonna take my picture, and everything on the bottom comes up. So, is that trapezoid on the bottom?
No.
Yep. Now, you're not changing its size, so it's still over 1, 2, 3, 4. But now instead of these points coming down, they're going to go up. So it's the exact same trapezoid, just drawn on top. So every point, if you label your points, you went left 1, down 1. Now you're going to go left 1, up 1. Now what about the big triangle? Is he changing? No. Because the positive things, the things on top, stay on top. So you're just going to draw him exactly the same way he was originally. Now, what about that guy? He's going to go up. So instead of being 1, 2, 3, 4, over 5, down 1, he's going to be over 5, up 1. he is. There's the bottoms up transformation. All right, look on the back side of that page. It's gonna be the same general shape that we want on the back side, so 8 through 15, look them over, which one looks like a good one for 8 through 15? Which one? 13. Now, actually, I'm kind of lucky. I'll do 13, but then I'm gonna do another one, because what's happening in 13? Aren't we just taking what we just did
Oh.
and moving it up one? Does that make sense to you, Daniel? So, well, I'll do another one, but I'll go ahead and do this one too. We're gonna lift it up one. So now you have lines on your paper, so you have a line up one, so everything is coming up one. So there's my trapezoid. Here's my triangle. And there's my other triangle. So the red is what the answer to 13 would look like. Okay, let's pick another one on that side, 8 through 15.
11.
Which one? 11? 11. Alright, so let's pretend it's the quiz. What changes are we making? Describe in words. One more part. What by -3?
Height.
The height. You gotta say that, because we can also multiply the width too. We're not. We're multiplying the height by -3. So what's that gonna do? It's gonna turn it over and stretch it, right? What else are we doing in that problem?
Up one.
Up one. All right, so I'm gonna do the height thing first. All right, so here we go. So I'm gonna take my original picture, which is this guy right here. Okay? And in the original picture, how far down does this trapezoid go? Left one, down one? If I times that by -3, it's gonna go left one and up 3? What's this height? -1? What's -1 times -3? 3. So I'm gonna go left one and up 3. And the same thing for that point and that one. So now my trapezoid is pointed up because the negative makes it go upside down, right? And 3 times as tall. Now what's gonna happen to this triangle? How tall is he right now? He is up 3. Oh boy, I'm in trouble. He's up 3, so he's gonna go down 9. I just messed with my scale, so it's really a lot bigger than that, but I didn't have room, so that's down 9. And what about this little one? In the original, he's down 1, so he's gonna be up 3. Now we're not done yet with the problem, but is everybody okay with this part of it? We okay with that? Okay. Now, I have to pick it up 1. So again, you've got lines on your paper, so you got a line right there. And every point is gonna come up 1. So there's my trapezoid. Now he's just coming up to here. There's my triangle. There you go. So the pink would be the final answer to the problem. with everybody? All right, let's go over to the next page, graph practice 2. We have a different shape, but we'll do one of each of these two. So this one, we have down 2 again. Oops. And then we got a weird thing there. Let's see, over 2, up 3. Over 3, up 2. And then 1, 2, 3, 4, 5, 6. Okay. All right. Which one do you want to do? 1 through 7. 1. All right. What? There's only one change happening. What is the change that's happening? We're dividing the width. So the height isn't changing, but we are dividing the width. So what is the width of this whole thing? How wide is that triangle? 4. So the new width is going to be 4 divided by 1/2, which is 4 times 2. So the new width is 8. So 1, 2, 3, 4, 5, 6, 7, 8. So now my triangle is 8 across. Now see that point right there? He was originally 2 across. Now he's going to be 4 across. We're on number 1. So 1, 2, 3, 4 down. So does it make sense to you that the vertex of the triangle would be halfway, just like it was here? So there's my triangle. Now I have to do this M thing. Well, how far across is it? 1, 2, 3, 4, 5, 6. Now it's going to be 6 divided by 1/2, which is 12. 1, 2, 3, 4, 5, 6, 7, 8. You may not even have enough room on your paper. Just keep it going into the next problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, now, where do I put the M part of it? You know, the top part of it. Well, how far over was that first bump right there? It was over 2. So now it'll be over 4. So 1, 2, 3, 4. This guy, the bottom of the M there, he was over 3, so now he'll be over 6. 1, 2, 3, 4, 5, 6. And he was, oh wait, that was up 3. This one is 1, 2, 3, 4, 5, 6, up 2. And then that, it's hard to tell from my picture, but I think it's over 4. So it's gonna be over 8. 1, 2, 3, 4, 5, 6, 7, 8. And it's up 3. So there's your M, but of course it's all stretched out because you basically doubled the width. All right, one more for practice. Let's go to the back side. We use the same shape. Pick one from the back. What would you like to do back there? 8 through 15. Eleven. 11. What are the changes that are happening in problem 11?
Splitting.
We're multiplying the height by -3, which basically means, another way of saying that is, you're gonna make it 3 times as tall and upside down. Does that make sense? And then, once you get all that done, you're going to move it up 1. We're doing 11 on the back. Yes, down to 11. So this is the shape we're using. We're gonna turn it upside down and make it 3 times as tall. So I'm gonna have the same problem I had last time, so change this a little bit. Okay, so here we go. This guy, this original triangle, was down 2. So instead of going down 2, I'm gonna go up 6. Remember, we're multiplying what we did. We went down 2. -2 times -3 is +6. Let's go into the other side, flipping. Now this this M thing is going to be 6 across. This first point, that guy right there, is over 2, up 3. So now he's going to be over 2,
Down 3.
down
6.
9. Aren't we timesing by 3? So we're going to go over 2, down 9. This one was over 3, up 2. So he's going to go over 3, down 6. Over 4, up 3, over 4, down 9. Now we're not done, but we've turned it over and multiplied the height or stretched it by a factor of 3. Is that all right with everybody? So what now? Take the whole shebang up 1. So here we go, here we go, here we go. There's my triangle, up 1. Now these guys are only coming up 1, so they're still going to be way down here. Is that okay with everybody? All right. Now, there's obviously tons of problems that we haven't done yet. The answers, I did them all. The answers are in Canvas. So if you want to practice more, you absolutely can. Okay? Our quiz is Friday. Today's Wednesday, yeah. And we don't have class tomorrow, so our quiz will be Friday. So if you do some practice and you want to bring it into office hours, we can look it over if you don't get it right. Okay? All right. Let's set that aside then, and let's get our notes out now. And we're going to continue on with our notes. Not for the very first few, but we're definitely going to be needing our graphing calculator. We might get to that today, but we're definitely going to need it tomorrow, so make sure you're ready to go. So we're going to do a little section on some basic kinds of word problems. many of which you've done before. But we're going to practice them. So here we go. Write an expression. Okay, get your notes out now. Get your notes out. Write an expression for 6 more than twice a number. 6 more than twice a number. Right there. Yep. Right down here. So who can do that? What's 6 more than twice a number? What would that look like?
6 plus
2x or n or p or a, whatever letter you want, right? 6 more than 6 plus 2x. Easy. Now be careful with this one. 6 less than 4 times a number. What do you think about that one?
6 minus 2,
4x minus 6. When it's 6 less than, that doesn't mean 6 minus. That means you have 6 fewer than 4x. So you got 4x and you're going to take away 6. Gotta be careful with that. 6 less than means minus 6. %, of a number. Do you remember from first year algebra, or summer school even, if you were with me in summer school bridges, Mrs. Field and I, what decimal is 24%? Nazir? 0.24. And in mathematics, the word of always means times. So when we have 24% of a number, that means 0.24, that's the decimal for 24%, times x. Now D, I go to the store and something costs X dollars. It's on sale though for 15% off. Now, how many of you are thinking right now that you're going to take that X and multiply it by 0.15? 15% of the cost? That isn't the best way to do the problem, because what does that tell me? If I multiply, let's say I want to buy this jumper and it costs $6. If I multiply 6 times 0.15, what does that tell me?
How much you get off of
How much I don't pay, right? And what am I interested in? Not how much I don't pay, but how much I do pay. So instead of multiplying by 0.15, I'm going to multiply by 0.85. Because if I'm not paying 15%, then I am paying 85%. Would you agree with me? If you do it the other way, you have to subtract it. So it's an extra step that's totally not necessary. Multiply by the percent that you're paying. Okay? Now, in addition to that, I gotta pay tax. So I go in to buy my jumper, I'm gonna pay 85% of whatever it costs, $6. But then I have to pay tax when I get to the checkout. Right? I'm gonna multiply, how much is my tax? 7. I'm gonna multiply by 1.07. Now, before you start getting all confused, if something is on discount, that comes off the price, right? The discount comes off. What does a tax do? A tax doesn't come off, a tax goes added on. This number is 100% minus the discount, because discounts come off And this number is 100% plus the tax, because a tax goes on. So we always multiply by 1 or 100%, 1 or however you do it, 1 minus the discount and 1 plus the add-on. So this would be the setup for the problem. So if I knew how much my jumper costs, let's say it is, I'm at Goodwill at $6. If I take 6 times 0.85 times 1.07, that's what the cash register does. That's exactly what the cash register does. It doesn't subtract or add, it multiplies. And it says I'm gonna pay $5.46 for my jumper. Now, I made up the $6 number that wasn't in there. I said, if it were 6, this is what I would multiply by, and that is the answer I would get. If it were a, you know, I don't know, $100 jacket, $100, 0.85, 1.07, and that would give me my cost. Go down to H. The final cost of an item, the original price is X. There's a 20% discount. So what am I gonna multiply by? If there's a 20% discount, I'm gonna multiply by 80%, not 0.20. Stop, stop, stop. When I go to the store to buy something, I want to know how much I'm going to pay. That's what they asked me for. If I'm not paying 20%, then what am I paying? 80%. So I'm gonna multiply by 0.8 or 0.80. This is 1 minus that 20%. Because a discount comes off. But then I still have to pay my 7% tax, so what do I multiply by? 1.07, because I have to add on the tax. I'm paying 100%. I start out paying 100%, but then they take away 20%, and then they add on mine 7%. And you can't do that. Like, you can't say, oh, if they take away 20 and add on 7, that's like taking away 13. No, it doesn't work that way. You have to do it in 2 separate multiplications. All right? I go to the restaurant. My meal costs X dollars. I'm gonna tip the waitress 20%. What do I multiply by? 1.20. A tip is an add-on. A tip is an add-on. I add it onto my bill. But then I also have to pay sales tax. 8% sales tax. What am I gonna multiply with an 8% sales tax? 1.08. Add-ons, whatever you're adding on, whatever is increasing your cost is gonna be 1 plus that percentage. Whatever is decreasing your cost, like it's on sale or I have a coupon or something like that, it's gonna be 1 minus. Okay? All right, so what did I skip? E, my salary after a 7% raise, okay? So, this is how much money I make right now, okay? X. Principal comes in and says, oh, Lisa, you're doing a great job, we're gonna give you a 7% raise. What would I multiply by if I'm gonna add on 7 more percent? 1.07. Now, what if she walks in and says, Lisa, not doing too well, we're gonna take away 7% of your salary, we're gonna cut your pay 7%. What would I multiply by if she's cutting my pay 7%?
Would it be 0.07?
No. No negatives. What did we do when we went on sale over here? 0.93. So let me say this one more time, guys, one more time. Start with whatever your initial amount is, and when we get to the actual problems, we'll have numbers, but right now we have an X. If it's an add-on, if it's something that is increasing that, 1 plus it. So when she was giving me a 7% raise, it was 1 plus 7%. Okay? If it's a takeaway, it's 1 minus the percent. So this is 1 minus 7%. All right? Now, here's what I want you just to think about this for a minute. Let's say you make $10 an hour. I was keeping an ICC number. You make $10 an hour. And your boss comes in and says, hey, we got cutbacks going on. We're gonna cut your pay 5%. Okay? And you wanna know, okay, so what's my new pay going to be? What happens if you take 10 times 0.05? It's 50 cents. Are you going from $10 an hour to 50 cents an hour? No. If he's cutting you 5%, you're still gonna get 95% of what you had. So you're gonna multiply by 95%. Okay? Never, ever, ever in these kinds of problems do you multiply by the actual percent. You either multiply by 1 plus it or 1 minus it. Okay? All right, what else do we have? The area of a rectangle. Okay, so you all know what a rectangle looks like. And our job is to find the area of the rectangle. And the width is 3 less than the length. So something's X. We're gonna put an X in this problem. Here. What would this be then?
3.
Not just 3, it would be 3 plus X. Isn't the length 3 more than the width? So if you call this X, then that's gonna be 3 more than it. Now, you could have also called this X, and then what would this be? X minus 3. That would be perfectly okay too. You would get the same answer in the problem. How do I find the area? I'll go back to this original one. How do I find the area? Length times width. So there you go. That would be your setup. One more rectangle. And then we're going to actually do some problems. The perimeter of a rectangle, okay, so I gotta find the perimeter of a rectangle, whose length is twice the width. So put an X somewhere here. And then this would be 2X, twice the width. What do we mean by perimeter? Add up all the sides. So that would be X plus 2X plus X plus 2X, adding up all the sides. So that is 6X for the perimeter. All right, here we go, number 2, need your calculator, we're gonna do multiplying here. Says your favorite teacher received a 3.2% raise. So we're adding on 3.2%. What is the decimal for 3.2%? 0.032, very, very good. Remember with percentages, we move the decimal point how many places? 2? Yep. So, yep. So, how much did the teacher make originally? 1, 2, 3, 4, 5. And what am I gonna multiply it by, since this is a raise? 1.032, very, very good. So then I'll get out my calculator. 1, 2, 3, 4, 5 times 1.032. And she's gonna make $12,740.04. Anybody want to take a wild guess what my starting salary was back in the fall of 1981 when I started at Cathedral? Actually, you're very close, but it was slightly more. I actually made $6,800, but I also got paid $400 for being the yearbook moderator, so I actually made $7,200. Wow. That wasn't very much. Even back in those days, that wasn't very much. All right, B. Last year, a Precal book cost $89.50. $89.50. This year, it costs $97.75. Find the percent of increase. Oh my. We did these back in summer school. Willow, you remember? You remember how to do them? No? Does anybody remember how to do percent? It's called percent change. Sometimes it's increase, sometimes it's decrease. You're getting close. You're on the right track. The formula for percent change, any change, whether it's going up or down, is the difference of the two values. So the difference of these two, which now, as you've already figured out, is what? What did you get? 8.25. Divided by, anybody remember now? It's the difference divided by the original. So our original was $89.50. So we're going to do that division. 8.25 divided by 89.50. And it looks like our increase is about 9.22%. So I got a decimal and I typed that in, but it says, what is my percent increase? So I'm going to change this to a percent, and then I rounded it off to 2 places. So anytime you're asked for a percent change, percent increase or decrease, you're going to use this little formula. Find the difference of the two values, that means subtract them, and then divide by the original one. Okay, so here we go with letter C. A car was worth 2, 3, 4, 5, 6, and now it's worth 18,765. Find the percent of decrease. So what's the first thing we do? Find a difference, that means subtract. So 2, 3, 4, 5, 6 minus 1, 8, 7, 6, 5. I tried to give you numbers that were easy to type in. Is 4691. And then what do I divide that by? The original, which is the first value. Oh boy, that one is almost exactly 20%. So that would be a 20% decrease. This one was a 9.22% increase. That price was going up, this one is going down. Alright. Now we're gonna get this next one set up. I don't know. Actually, because I don't wanna interrupt it, let's skip D and E for a moment and let's go down to F. Because we can do F. Find the final cost of a sweater that originally cost $52.50. So there's the original cost of my sweater. It's on sale for 25% off. What am I gonna multiply by? That's my 3-year-old temper tantrum. Do I ever multiply by the actual percent in the problem? No. I multiply by 1 plus it or 1 minus it, depending on if I am adding to my price or taking away from my price. So let me say this once again. I have a 25% discount. What am I multiplying by? 0.75. That is 1 minus the 25, because discounts come off. There's a 7% sales tax. So I'm gonna multiply again, and what am I gonna multiply by? 1.07, because I am adding on the tax. So 52.50 times 0.75 times 1.07. You're gonna end up paying $42.13 for this sweater. One more, and then we'll be done for the day. Take a minute and set up G. Set up G. Type it in and get an answer. We got 2312. We're gonna multiply it by 2 things and get an answer. Who got an answer? Mary, what you got? 28.45. All right, let's check that. See how she did. That's what she said she's gonna pay. So there's a 7% tax on the food. That's an add-on, right? So I'm gonna multiply by 1.07. There's a 15% tip. That's another add-on. So I'm gonna multiply by 1.15. Oh, yeah, because it actually comes out to be 28.449, but since it's money, we have to round it off here, and that'll go up. Yep, beautifully done.
Good
Perfect,
job.
perfect. Everybody okay with that?
Yes, ma'am.
So every change in the problem, the tip added on, the tax added on, we do a multiplication, and the multiplication is always 1 plus or minus